Okay, this is the midterm exam study guide video. I'm going to show you the example, and then I'm going to have you try one on your own. Those are the ones I'm grading, the ones I'm having you try on your own. But here we go. First problem is going to have you take a value for x and plug it into the equation in function form where that x is. But we're going to show this in function notation. The function, when I plug in x is 3, that's what this is showing right here. The value of it comes from me plugging in -3 right here into x in this equation and following order of operations. That gives me the function at -3 is -6 minus 5, or the function at -3 is -11. And why we like function notation? Because it's very descriptive. It shows us when I'm plugging in -3 for x, it's showing me that all the way down, showing me what I'm plugging in for x. The y value gets spit out as -11. So again, know that if I was to technically graph that, that's the x-axis, y-axis. When x is -3, y gets spit out as -11. I'm going to have you do the same for this problem. Plug it in -4 for x, showing this weird function notation again, showing what number you're plugging in for x, what you're getting for y, right as a coordinate. All right, next problem, number 2. This one is giving you a function as kind of a word problem, having you plug in d is days into this d spot to calculate the cost. So it looks like cost comes from $10 per day. Looks like a $30 deposit, $30 y-intercept number right there. So the cost after 5 days, again, using this, just showing function notation. The cost after 5 days, plugging in 5 for D, comes from the $30 deposit plus the $10 they're charging per day. And how many days? 5 days. Gives me the cost after 5 days is 30 plus 50. Make sure you times right there. Never add before you times. And that gives me the cost after 5 days is $80. And again, why this is good, it shows me that 580 means the cost after 5 days, the function spits out $80. That's what that is. All right, so I'm going to have you do the same for this one using 4 days and a little bit different situation, maybe only a $25 fee, but a little bit extra, charging $15 per day. All right, number 3, this problem asks you to identify the data, that is not a function that breaks the function rule where you have an input spit out 2 different outputs. So for me, focus on just the input numbers. If none of those repeat, your money. Looking at these guys, I could tell if my input's repeating by any double arrows shooting out of them. All right, and again, looking at this, if none of your x numbers repeat, that's probably going to be a function. Yep. So none of these x numbers repeat. Don't even look at those y numbers. That's a function. So that one is good. The next one I look at shows an x number spitting out a 3, and then I have that same input number spit out a 4. You cannot have that. This is the one that's not a function. They want to identify that. This one down here is a function. This one is good. Just like A was, because I have no double arrows. Remember, if I had 2 arrows shooting out of one of these input numbers, that would be an input spitting out 2 different outputs. Then that would be not a function. But the way this input output table set, little ovals, none of those arrows are double shooting out of the input numbers, so that's good. I'm going to have you over here for this one identify the 2. I spit out 2 of these that show an input given 2 different outputs, an input given 2 different outputs. Can't have that. All right. And again, for that, if I wanted my data up here to show an input having two different outputs, I would have maybe a 3, and then instead of 3, maybe spit out a 5. That would be an input spitting out two different outputs look for coordinates. All right, hopefully that helps. Do number 3. All right, number 4, the first of the brutal interval notations, looking at domain kind of way, looking at those x-axis numbers. Always focus on those x-axis numbers for domain, and only look at the y numbers for range, but x-axis numbers for the domain and intervals. So here I go. For the increasing intervals, it's going right here, starting from -5 on the x-axis, and that little stretch they're going to break up going to -4. And again, I write that as that -5. Inequalities always go this direction. X in the middle, inequality, and I'm going to put -4. That's one of them. The next little stretch goes from -4 and ends at -2. They want you to describe both. So that next little stretch where it's going uphill from -4, inequality, always this direction, to -2. Those are the two parts where it's increasing. Decreasing, looks like I got two stretches. And again, looking at those x-axis numbers to describe. So from -2 all the way here to 1. So that looks like the first stretch where it's going downhill. Inequalities always this direction from -2 to 1. And then looks like from 3 to 5 where it goes downhill. And again, I know usually we put those little lines under there, but looking at the examples on the final exam, they're going to write it just like that. All right, maximum, this high point right here, written as a coordinate. For this one, that maximum is -2 for x, up 3 for y. Know how to write a coordinate. Your minimum, which is this coordinate right here, the lowest point, my minimum, the lowest point of my data, looks like 4 for x, -4 for y. Again, max and min, highest, lowest point. Know that, write it as a data point, regular coordinate. All right, I'm going to have you do the same for this one, where I have clearly two stretches going uphill. I got two stretches going downhill. I got a clear maximum and then a clear minimum. All right, do that problem. Number 5, here we go, moving on. This one, I want the domain and range, but we're not going to use interval notation. We're going to use that set notation using symbols. So my domain, measure from left to right, looks like I have definitely a boundary right there for my domain at -4. So that my domain is going to be square bracket -4, and then that arrow going down, I know it's going downhill, but it doesn't matter. Domain measured left to right, that would be positive infinity rounded. So again, this one is square. Clearly try to draw that even better than me, square, and then this one is rounded. Make sure I can see that clearly. Set notation for range is measured from bottom to top. This one's going to be a little difficult here. So again, bottom to top, since this is going down, there's no bottom to it. So my bottom of my range goes from rounded -infinity, because anything measured bottom to top going down is negative, up there to this 2 on the y-axis, square bracket. And again, it's got to be in that exact order. This is rounded because there's no bottom to it because of that arrow going on forever. And then square because the top part of my boundary right there is a solid data point. And again, range, bottom to top, looking at the y-axis numbers. Domain, left to right, looking at the x-axis numbers. Do that for this problem right here, number 5. All right, moving on. Number 6, what is the domain? The domain, if you look at coordinates, if I give them to you, and again, this is my x-axis, This is my y-axis. My domain are all my x numbers. Those are my domains. The domain of this data are all of my x numbers from here. So here we go. I got 1, I got 3, 4, and 5. Again, technically those are coordinates, of course, but all I'm interested is the first number, the x number. I don't care about the y number. Those are my range numbers. I want the x numbers. So here we go. 1, 3, 4, 5. Those are the domain. If I wanted the range, I would have asked you to give me the y numbers from those coordinates, 10 and 30 and 60. It looks like maybe 100 up here, but I didn't ask for a range. I asked for domain, the x-axis numbers, the x numbers in that data. So do the same for number 6. Give me the x numbers. All right, number 7. This one, again, the function test. Which one shows a function? That last one was not a function. This one, which one shows a function? And again, you know it shows a function if none of your x numbers repeat. That's what we're going to do at this level. Don't worry about any tricks. If none of your x numbers repeat, it's money. It's a function. If none of these x numbers are the same, it's a function. But if you do have x numbers that are the same, it's probably not going to be a function. Nope, not going to be a function. So looking at this first one, all of these x numbers are the same, and they're spitting out different y numbers. So that one is terrible. No way that's a function. Can't have all those x numbers plugging in one and getting different y numbers. This next one here, none of these x numbers repeat. I don't care that all the other numbers are 3. That doesn't matter. If none of the x numbers repeat, that means every input has only one output. This next one, these are not the same. These are not the same. None of these x numbers repeated. As soon as I see that, I know it's good. This one, I got a 4. Uh-oh. 1 4 gives me a 1. This 4 over here, another a different. There we go. Can't have that. That one is no good. So you can see the only ones that were a function were those middle ones. I'm going to have you do the same for this problem right here, number 7. All right, moving on. This one, it wants all the terms that apply. And remember for this one to review, if it's going downhill, okay, let's do the first part. Dots or no dots. If it has no dots, we consider that continuous. If this instead was just a bunch of data points, then that would be discrete. But this one didn't have a bunch of points. It was a solid line, so continuous. Next category, straight, linear, or curved exponential. This one's definitely curved, so this one would be exponential, curved. If it's straight, like an arrow, linear. And my next category, going uphill from left to right, or is it going downhill from left to right? Always measure from left to right. This one is definitely decreasing because it's going downhill. Always we measure from left to right. So I want you to do the same for this. Dots or no dots. Straight or curved. Going uphill or going downhill. All right, moving on. Number 9. This one, again, they give you the set notation answer, and they want you to find all that apply. Remember, there's more than one. So here we go. This one, starting at 2, it looks like trying to bait you. But remember, domain is measured from left to right, looking at those x numbers. So this one would really be 0, infinity, which means that one's no good. This one right here starts at 2, and I know the arrow's going downhill, and most people are thinking, oh yeah, that's clearly 2, but that's negative infinity because it's going downhill, and they don't pick that one. But nope, that one is true. I don't care that that one's going downhill. Anything domain-wise is measured from left to right, and that is going left to right. That's positive infinity. That one is one of the matching answers. That one, yes, is square bracket 2, positive infinity. Even though it's going downhill, it doesn't matter. Anything measured left to right, going to the right, positive. And then my next one here, 2, clearly I could see going square bracket from this 2 to left to right. Yep, there's my second choice. That one is money. This one is no good. This one would be from negative infinity to 2 square. Always measure from left to right. So that one is no good. Those are the only two that match. So I want you to do the same for square bracket 3, positive infinity. There's more than one answer. All right, moving on. Number 10, solve for the given variable. I'm going to start by taking away this 40, or even better yet, I'm going to suggest to my whole class, do a flip right away. Use the associative property, flip it, because it makes it easier when you're solving for this variable right here to have that on the left side. Most of you are more familiar with that, so flip it. And then solve for g by taking away that 40 first. These will go away. Bring down that 5g, just like you would a regular equation. P minus 40, I can't do anything with them, just write them like that, P minus 40. And then my next step, I'm going to divide everything by 5, both sides by 5. But remember, when I do that, when I divide both sides by 5, I'm really dividing both of these parts over here individually by 5. So my final answer, when that 5 cancels away, is G all by itself, solved for, is P over 5, and then negative 40 minus 5 is negative 8. I'm going to simplify that because I can. I can't simplify P over 5 because I don't know what P is. All right, do the same for number 10. Flip it, please. I'm telling you, use associative property. Nothing changes when you flip stuff around. It's still the same. All right, here we go. Number 11. This one, the harder one, hardest problem on the test algebraically, where you're distributing, and then after that, combining like terms, and then of variables, both sides. Here we go. Negative 9x. Negative 3 times negative 3, positive 9 plus 6x. Bring down the rest. This is negative 1x, if that helps people out. Next step, combine these like terms. Leave that 9 alone in the middle. Negative 9 plus 6 gives me negative 3 of those x's. Bring down that 9. Bring down the negative 1x. Bring down the plus 3. Now it's a variables on both sides. Start by getting rid of the 9, and then you're going to do the opposite and plus 1x, and then you're going to divide. Always stair step it, left, right, left. First step, get rid of the plain number on the left by doing the opposite to both sides. Bring down your negative 3x. Bring down your equal. Bring down your negative 1x. 3 minus 9 is negative 6. Stay on that side. The opposite, adding 1x. That's the opposite of negative x. Adding 1x. We'll make those eliminate and give you over here negative 2 of those x's equal negative 6. Divide by negative 2 to help you out. Answer is going to be a nice, neat whole number answer. If it's not, something went astray. X equals nice, neat, positive 3. All that madness, nice, neat, positive answer at the very end. The same will happen to you if you do this correctly, I promise. All right. Number 12, solve the inequality. Show me you understand by giving me a few numbers. So this one, all the same inverse operations we just did, but to an inequality. Don't put an equal in there. That inequality, based on the way its direction is open, you gotta know this is more than. Less than looks like an L, but this is definitely more than. 20 minus 3 is 17. And then right there, the opposite of timesing by 4, dividing by 4, which will make these cancel away, and gives me the answer for x are all numbers more than, and if I do 17 divided by 4 my calculator, all numbers more than 4.25. I like to have you spell it out in words. More than 4.25, because I want you to be able to give me some numbers that are more than 4.25. So how about 5, 6, 7? Those three numbers are more than 4.25. I want you to solve for this one and then give me three numbers that satisfy this. Remember, this one looks like an L. This one is less than. So when you solve this, I want three numbers less than that answer. All right, here we go. Moving on. 13. This one, the last problem to get you ready for the last concept when we come back from winter break. Special case situations here. So again, this one, they're kind of disguising them, but I still need to have you to be able to distribute. I got to have you know how to combine like terms. But again, on this, once you get past that first little step of either distributing or combining like terms, remember 5x plus 12, you could either solve it or you could see that these x numbers are the same, and then these plain numbers are different. Whenever I see that, that's going to be a parallel line situation. They have both have a y-intercept. Oh, one has a y-intercept of 10, one has a y-intercept of 12. So again, when we're changing these into equations, these equations, one would start at 10 with a slope of 5. The other one would start up at 12 with a slope of 5. When we start putting these equal to y, which we're going to start to do, those are parallel. But to get you ready for that, if you solve one of these and they have the same numbers different, it's going to be a no solution answer. No solutions. And you know, because if you went to solve this the normal way, this is what happens. And I want you to show this. That gives me 5x equals 5x plus 2. And then if I take away 5x right here, if someone was to keep going, they would be left with 0 equals 2. That's your look. That tells you, again, this is a no solution. If I was to do this math and I would get equal numbers like 0 equals 0, that would be a many solution. Remember going over these many solution. Or for those of you listening, if you get equations and you could see that they're the exact same, not only the same number in front of x, but the same y-intercept number, that's a quick way to know it's many solutions. But again, if you solve all the way and you get to two equal numbers, many solutions. So trying to set you up for 13, which is obviously going to be a many solution or an infinite solution to help you out on that one. All right, good luck. Talk to you in a bit.